The structure we are about to create is composed of a metallic truss placed on 2 point supports. We will apply point loads, impose displacements and thermal loads. Launch Advanced Design and start a new project. Skip the first page by clicking Next, and on the second page define your default settings for the project. Choose the workspace type by selecting the Plane Radio button. Deselect the Bending Rigid Structure option. Click this button to open the Materials dialog box. Here select the S235 steel and click OK. Click Finish to close the Project Settings dialog box. We are now going to create two user-defined cross-sections by entering their cross-section properties. From the main menu, select Edit Used Cross-Sections. In the Description of Defined Geometries dialog box, click Add. On the User tab, expand the User Sections library and select User. Click Modify, then Add to create a new row in the User Cross-Sections table. Enter the cross-section names in the Designation column and the cross-section parameters in the following columns. Select section A1 and click Import to add this section to the current project. Do the same for section A2. Select the Create a Linear Element icon from the Modeling toolbar. Choose the Linear Element type Bar. Click inside the Cross-Section Extremity 1 cell as shown here to open the cross-sections libraries. Select the A1 cross-section from the user table in the User Sections library and then click OK. Now create the horizontal bars either by snapping to points on the grid or by typing the end coordinates in the command line. For the vertical and diagonal bars, switch to the A2 cross-section. You can select this from the drop-down list shown here. First draw the vertical bar by snapping between the left extremities of the two horizontal bars as shown here. In the command line, enter the coordinates for the first two diagonal bars. Select the two diagonal bars and click the Allowed Deformation icon. When you click this button, the blobs on the ends of the selected linear elements will turn blue or red. When the blobs are red, moving the blob stretches the linear element by moving the selected end and leaving the other end where it is. When the blobs are blue, moving the blob moves the whole linear element without any stretching taking place. To copy the selected bars, hold down the Control key, then click on the end of the bar as shown and click again in the place you wish to copy to. Keeping Control held down allows you to continue to create copies. Press the Escape key to stop copying. Add the remaining diagonal bars as shown by snapping to the endpoints as shown. Next we want to split the horizontal bars where they connect to the diagonal bars. We do this as follows. Select the diagonal bars as shown. Select the Subdivide command from the CAD Modifications toolbar. Click the two horizontal bars as shown here. These bars are cut by the selected diagonals that intersect them. Now let's add the supports. Select Create a Rigid Point Support from the Modeling toolbar. In the Properties window, select the Hinge Restraint type. Create the support at the base of the left vertical bar of the truss. For the next support, select Other as Restraint type and deselect TX. This will allow movement in the direction of the global x-axis. Now let's create the loads. In the pilot, select Loading, right-click and select Create a Case Family from the context menu. Select the Live Loads family and click OK. A static load case, 1Q, is created automatically under Live Loads family. Right-click on Load Case 1Q and select Create a Load from the context menu. Select Point Load and click OK. In the Properties window, enter the FZ intensity, -150 kN, and place the point load as shown. Modify the FZ intensity to -100 kN and create the second point as shown. Right-click on the Live Loads family and select Create a Case and click OK to create another live load case called 2Q. Select the 2Q load case and from the Generate menu, select Impose Displacement. Enter the DZ value, -0.02 meters, and add the displacement load at the left extremity of the truss base. Define the DZ value, -0.03 meters. Create the displacement at the base of the lower truss triangle. Define the DZ value, -0.015 meters. Create the displacement at the right extremity of the truss base. In the pilot, select Loading, right-click and select Create a Case Family. From the context menu, select the Temperatures family and click OK. A temperature load case called 3Temp is automatically created under Temperatures family. Temperature loads are generated by default on the entire structure. In the pilot, select the temperature load case. In the Properties window, define the Uniform T value 150 degrees C and make sure that the automatic generation is set for all. To analyze the model, click the Analyze menu and then click Create the Analysis Model. Select FE Calculation, then OK. Click on the Results Settings icon on the FE Results toolbar to open the Results dialog box. Click the Case Combinations button to see what load cases are selected for display. Make sure all load cases are selected. From the Analysis FE Results toolbar, select the Displacements result type, D, Results on Linear Elements, and the load case 3Temp. Open the Results dialog box again. In the Options tab, from the Values on Diagrams options, select Extreme Values. Slide the cursor towards Max to increase the font size of the displayed values. Click OK to exit and display the result. Open the Result dialog box. In the FE tab, select the result types Forces, the element type Linear Elements, the results coordinates Fx, and the display mode diagrams. Click Case Combinations and in the Analyses and Combinations window, Forces tab, select only 1Q. In the Options tab, from the Values on Diagrams options, deselect Extreme Values and select Values on Diagrams. Click OK to exit and display the results. On the Analysis FE Results toolbar, choose the result type Stresses, the result coordinates for the linear elements SXX, and the load case 1Q. Click the Create the Post-Processing icon to view the stresses.